Alright, so today we're going to work on the triangle inequality theorem and Pythagorean theorem converse, which are the last two of our 6 key ideas for this standard. Okay, so the triangle inequality theorem says that the sum, okay, which means remember we're adding them together, sum of the lengths of any two sides of a triangle, okay, must be greater than the length of the third side. Okay, so let me zoom this out so we can see the whole thing here. The sum of the length of any two sides of a triangle must be greater than the length of the third side. Okay, so note here, if you test the sum of the two smallest sides and they satisfy the theorem, that all other sets or pairs of sides that you choose will as well. Okay, so the first statement says the sum of any of the lengths of any two sides must be greater than the third side. So it kind of makes you feel like you're going to have to test 3 different things, right, to test any two sides. But the note here says if you test the smallest two sides and it's greater than the third side, that also satisfies the theorem. So you really only need to identify the two smallest sides, add them together, and if it's greater than the third side, then you're good. Okay, so to determine whether each set of side lengths will form a triangle here, okay, I am going to do just the smallest two sides. So if I have sides of 5, 8, and 1, my smallest two sides are 1 and 5. So if I add them together, I'm checking to see is it greater than the third side, which is 8. I get 6 is greater than 8, not true, which means it's not a triangle. Okay, and I have on my sheet that this is an 11. So let's do that just in case the notes say it's 5, 8, and 11. If I have side lengths of 5, 8, and 11, so this is kind of like another problem. Okay, if I had 5, 8, and 11, then I would add 5 and 8 to check to see if it's greater than 11. 13 is greater than 11, so yes, it's a triangle. Okay, next one. It looks like the last numbers are all getting cut off here. 8, 4, and 12, this should be 8, 4, and 12. And this one is also should be a 12 on the third one. So if your notes say 1, get that corrected to be 12. Okay. Alright, so sides of 8, 4, and 12. Then I take my smallest 2 and add them together to check to see if it's greater than my third side. Is 12 greater than 12? It is not, so it's not a triangle. Okay. Next one. Alright, this is where you might check. Okay, what is 10 square root of 2? So if I throw my calculator 10 times the square root of 2, I get that it's 14 point something. So I'm just going to make a little note here. 14 point, and I put dot, dot, dot because it's point something, right? So my smallest two sides here are actually 10 and 12. So I'm checking to see if 10 and 12 are greater than 14 point something. Okay, which is the 10 square root of 2 as a decimal. Okay, so is 22 greater than 14 point something? It is. So it is, that's an I, it's a triangle. Okay. Next one, again, if you feel like you've got it, go ahead and pause it and do those next 3 on your own. Okay. So here I've got 16, square root of 26, and 23. So square root of 26 is 5 point something. Okay. You can throw it in your calculator, but you also know 25 is a perfect square. So it's a little over that. So I'm going to add these two together, 16 plus 5 point something, to check to see if it's greater than 23. Okay, so 16 plus 5 gives me 21 point something. Is it greater than 23? It is not, so it's not a triangle. Okay, square root of 13 is going to be 3 point something. If you throw it in your calculator, you get 3.61 something. Okay, 2 times the square root of 5 would be, square root of 5 would be 2 point something times 2, so it would be 4 point something. Looks like 4.47 something. 4 times the square root of 2, throw out my calculator, I get 5.6568 something. Okay. So, is 3.61 something plus the 4.47 something greater than 5.65 something? Well, 3 plus 4 alone is 7, so it is greater than 5. So yes, it's a triangle. Okay. And then we've got 3, 6, and 9. So is 3 plus 6 greater than 9? Well, that adds to be 9. 9 is not greater than 9. It's equal to it, right? So this one is not a triangle. Okay, so that's all we're doing for the triangle inequality theorem. Okay, the second part of this lesson, though, is the converse of that. Okay, so the converse here says if c squared equals a squared plus b squared, okay, we already know this is going to be what kind of triangle? It is a right triangle, and if you're like me, I prefer a squared and b squared to be on the left. It doesn't matter, but that's just how I look at it, okay? If c squared is less than a squared plus b squared, then the triangle is going to be acute. Okay, so remember acute's less than 90 degrees. So again, I like a squared and b squared to be on the left, so I can flip the entire inequality, and these would be the same thing. So it's a matter of personal preference, how you like to look at it. Okay, and then the last one then, of course, it's going to be if c squared is greater than a squared plus b squared, or if a squared plus b squared is less than c squared, then the triangle is going to be obtuse. Okay, one thing I use to help me when I have it written the way that I use it, acute is a smaller than 90 degrees, but my inequality is greater than, and that should be squared here. Okay, and obtuse is greater than 90 degrees, but my inequality is less than the c. Okay, so c, remember, is always your longest side. So, determine whether each set of sides forms a triangle. So we have to do what we did just on the last page, okay? If it does, then we classify the triangle formed. So first I have to check if 9 plus 10 is greater than 15. So 19 is greater than 15, so yes, it's a triangle. And now I have to classify it, so I have to determine what a squared plus b squared is to c squared. Okay, so when I add this together, I get 181. Squaring this gives me 225. So 181 is less than 225, making my triangle obtuse. Okay, next one. If I add my two smallest, I need to make sure it's greater than my largest. So 23 is greater than 17, so yes, it's a triangle. Now I need to check what is 8 squared and 15 squared added together to 17 squared. So if I calculate it, I get 289 and 289. Okay, so I have found they are equal. So this is what I'm trying to find, is are they greater than, less than, or equal to? And it's equal. So in this case, I have a right triangle. Okay, next one, I have to check if 4 plus 4 is greater than 5, and 8 is in fact, so yes, it's a triangle. Okay, so I need to check if what 4 squared plus 4 squared is to 5 squared, right? This is what I'm checking out here. Okay, so 16 plus 16 is 32. To 25, it is greater than. So if it's greater than, I have an acute triangle. Okay, and again, this is the way I'm doing it with this way. Okay, so if you do it the other way, totally fine. You do it your way, whichever way works best. Okay, next one. Square root of 14 would be 3 point something. So is 3 plus 3 point something greater than 5? 9 point something is greater than 5, so it is a triangle. So now I need to check if 3 squared plus square root of 14 squared, what that is compared to 5 squared. Okay, so this is where I'm checking out equal to, greater than, or less than. So I have 9 plus 14 and 25, which gives me 23 and 25. Okay, so still trying to check it out here, and I find it is less than, which makes it an obtuse triangle. Okay, and if it's not a triangle, then you just put not a triangle. Okay, square root of 41 is 6 point something. My smaller sides are 3 and 5, so if I had 3 and 5, is it greater than 6 point something? And it is, so yes, it's a triangle. So now I need to check if 3 squared plus 5 squared is what it is compared to the square root of 41 squared. This is where you go back, keep the square root, okay? So we're trying to figure out, is it greater than, less than, or equal to? 9 plus 25 is 34. And oops, not square root anymore after I square it, right? It's just 41. And it is less than. So again, I have an obtuse triangle. Okay, and then the last one. Okay, 2 square root of 5. Throw up my calculator so I can see it's 4.47 something. So my smallest two sides are 4.47 something plus 6, and I'm checking, is it greater than 7? Yeah, 10.47, etc. is greater than 7, so it is a triangle. Okay, so when I square my two smallest sides, 2 square root of 5 squared plus 6 squared, I'm comparing what it is to 7 squared. Okay, so remember 2 squared is 4. Square root of 5 squared is 5, plus 36. So 20 plus 36 gives me 56, and then I've got 49, which tells me it's greater than. And because it's greater than, I know I have an acute triangle. Okay, so that finishes up our standard 11. Okay. So I will go back to review. We started with finding a missing leg or a missing hypotenuse if we were given integer sides. Okay, we also found missing legs or hypotenuse if we were given radical sides. We applied the converse given integer sides and radical sides, and we can now determine if that a given set of sides does or does not form a triangle, and what kind of triangle. Okay. Oh, I didn't realize we had this down here. I can also form right answers in simplified radical form, right? Leave it in simplest radical form. All right, so that concludes standard 11, okay, for today. And in Class 48's lesson, so you should now be able to go ahead and complete that homework.